name is Collin. I work for the Google, and I'm also a core Python developer working mostly on Python 3 and this is here tool that you're hearing me talk about. And so today I'm going to talk to you about what 2 to 3 is, about the niche it fills as part of the overall transition strategy from Python 2 to Python 3. Talk about how to use it in particular, how to include it into your workflow for releasing products that work in multiple versions of Python. Talk a little bit about what it does, how it does what it does well, what it does just okay, and what it frankly really sucks at. And then talk about some of the feature requests and future direction for the tool that we have planned before the releases of Python 2.6 and Python 3 sometime this fall. So I'm going to start off with talking about what it is, why it is. Part of the transition strategy, Python 3 is a chance to get rid of a lot of the cruft that has developed over the dozen or so years, like almost 20 years now this project's been around. And because of that, we're taking this opportunity to break backwards compatibility with Python 2 in a lot of ways. Some of those ways are syntactic, some of it is semantics. And because we can't do what Perl 6 is doing in order to keep your snickering to a minimum. We can't do what Perl 6 is doing. What they're doing is giving you the ability to import Python 5 or Perl 5 modules. I did that in practice too. Perl 6 is going to give you the ability to import Perl 5 modules just natively, and it'll just work. Of course, you can also import Haskell and C and JavaScript if you want to. So they clearly have this figured out. But we can't do that because they have sort of an advantage that we lack, which is that there's only one version of Perl. There's only a single implementation. And so the implementation cost of all this ultra fancy backend infrastructure is concentrated into a single project. How many implementations of Python? There's CPython, IronPython, Jython, PyPy, Tiny Python, which I heard about here, and probably half a dozen more. And we can't ask all of these different projects to go ahead and implement a Python 2 VM inside their Python 3 supported implementation. So we have to have some way of translating both syntax and translating semantics in Python, and 2 to 3 is the syntax part of that. Python 2.6 will ship with a compatibility layer, a compatibility mode that you enable at runtime, and that will flag semantics, things that will disappear in Python 3, things that you're doing in Python 2 that are legal that will become dangerous or unsafe in Python 3, things that 2 to 3 can't easily pick up on. And so, things like translating the except statement into new syntax is easy, and 2 to 3 can do that without any problem. But things like this are a lot harder to translate to a version that'll work in Python 3. Who knows what's wrong with this? Or at least what will be wrong with it in Python 3. Core developers keep their hands down. No, it's not that really. They don't mean Unicode. Yes, you're adding Unicode to a byte. Because in Python 2, the bytes coming out of F are strings. And so doing this concatenation is legal. In Python 3, the bytes will actually be a bytes object, and this sort of concatenation results in a type error. And 2 to 3 can't easily detect that. And so that's what 2.6 will do. It will tell you, oh, hey, you're trying to add bytes and strings, and you shouldn't do that. You should fix that. And so the general, the projected workflow is that you'll maintain your code in 2x. When it comes time to do a release, you will run it through 2.6's compatibility mode, fix all the things that it complains about. You'll then run the resulting code through 2 to 3, and it'll fix all the syntax, so that you don't have to go in and manually hand tweak every single except statement, every single raise statement, get rid of every single instance use of a dictionary's has keys method, and it'll just do all that for you. And then you run your test suite. And I've gotten into arguments in the blogosphere with various people about how sympathetic I should be to people trying this progression without the test suite. And despite their arguments, my position is still, if you're doing something like this without a test suite, you're an idiot. A test suite is going to be absolutely critical to this sort of large-scale refactoring. And that's really what this is. It's just a colossal refactoring across your entire application. And so you need a test suite to make sure, a test suite with high coverage, to make sure that you hit all the code paths. For example, that 2.6's compatibility mode is only going to, it works at runtime, so it only works on the code that you run. So if your test suite has low coverage, then it's only going to be able to tell you about things you're doing in a small percentage of your code. So both of all of these things are going to be important and essential. So let's talk about how you actually use this thing. I'm going to do the stupidest thing possible, which is a live demo. So here I have a checked out version of 2.3. Can you all see that? That's as big as it goes. I'll just have to do a really good job of narrating. But so, have a copy of 2.3 here. And, hold on. The main program for this is called refactor.py, and because it is sort of a refactoring tool. Let's tell it to fix all occurrences of the map statement in this example file. And so it'll go through, and it will tell you that it will print out a little diff that tells you how things used to be and how it changed things. And we'll actually tell you down here that you are using, so it's basically map in a void context. You're using map instead of a for loop, and it chides you for that. You can detect that sort of thing. You can also get rid of all occurrences of has key. And replace it, replaces has key with in. So that's my next string. We'll run 2.3 over itself. While it's doing this, talk about a little bit what it's doing. It's a multi-stage process that first it parses all the files into an AST. An AST has been annotated with all the white space that was in the file. So it includes things like comments, it includes things like indentation, it includes things like new lines, blank lines between classes or function definitions. It includes all that so that when you spits the code back out, all that stuff has been preserved. It will then go through, and it has a collection of, I guess, getting up for about 30 different fixer modules. And each of the fixer modules is responsible for a single translation. There's one that's responsible for accept statements, one that's responsible for raise statements. And 2.3 will do a traversal over this AST. And actually does two traversals. An in-order, or a post-order or pre-order traversal. And it asks at each node, it asks each fixer, do you care about this? And the fixers have a little pattern, basically a regex that runs over a tree, written in a special DSL that Guido wrote for this purpose. And then so if one of them says yes, then 2.3 says, all right, well, what do you want to do with it? And it will provide the fixer with a particular node of the AST that it's on right now. And the fixer will do some fancy magic. And we'll get back to that in a second. So it's done, it's finished translating 2.3 itself. And let's see how good a job it did. Let's ask it for its full screen. I have a copy of Python 3 here. It's 3.0 alpha 3. All right. So that at least works. Now let's have it, since it fixed the example file that there. It still works. So it's been able to successfully translate itself to run under Python 3. Which I guess is a pretty good indication that it did its job right. And let's see, I was talking about the pipeline. After if it traverses the AST, it'll ask each fixer, do you care about this particular node? It says yes. And then it'll give it the opportunity to do something with that node. Some of them will inject, say, do a complete replacement. Some of them will scan over the surrounding context or even the entire namespace hierarchy, looking for, did you rebind this name at any point before we got here? So should we look for that sort of thing? And they're generally pretty good about return. Like, that's actually a very quick process, surprisingly fast. We'll get to more of the performance characteristics in a minute. Let's take a look at some of the fixers. They're generally broken up into syntax, semantics, and idiom fixers. And I have a selection of them here that you may or may not be able to see very well. This is the fixer for accept statements. And it fixes, it can do sort of the run-of-the-mill accept E, comma, T, change it to accept E as T, handles some other special cases that are less common, having to do with the fact that exceptions in Python 2 can be unpacked as tuples, which has turned out to be not such a great idea, just going away in Python 3. And here we see the little DSL that it uses to determine if it cares about a particular node. It's looking for a try suite with an accept clause and possibly finally. Inside it, it'll go in and patch all these up. Here's all the code to do the transformation. And there's a whole lot of little special macros that make all this a lot easier. It wasn't so easy a year ago. Then look at one of the semantic ones. This is the fixer to fix up map calls. And generally what it does is in Python 3, map will return an iterator. And so what this does in order to preserve compatibility is just tosses a list call around all maps. Except if you have map none, which is going away or its meaning being changed in Python 3. So it will convert that into a simple list call. There are also some other contexts where it knows to avoid doing certain transformations, and it has a fairly complex pattern you see here for doing all this. And then additional patterns for looking for different contexts that it might occur in, where it may want to do a different translation. This is the picture actually called idioms, which will replace type comparisons. So if you're doing like type X equals some other type, it will replace that with an instance call. And it can also do negative comparisons. I'll pick up on that as well. It will also convert while one into while true. And it does some stuff to make sorted calls more idiomatic. And then all of these are backed by a multi-thousand line test suite that is designed to look to stress each of the corner cases of every one of the fixers, making sure that they preserve white space and comments in all the appropriate places, make sure they don't accidentally mangle some of the surrounding bits, things like that. Let's talk about some of the limits of what this tool can and can't do. It can't do type inference. And I don't know if Brett's nailing it. There was one of the core Python developers spent his entire master's thesis investigating whether or not you can do type inference on Python code. It turns out you can't. Not really. We can do it for a very small subset, but not an interesting subset. And so 2 to 3 won't go and figure out if, say, what looks to be a has key method, is it really being called in a dictionary? That's not something that can be easily done. And so we just assume it is. It also can't follow variables very well. So if you do, say, like x equals something, and then in the next line, use x in an unsafe way, it can't really detect that. If you'd like to add support for that, I'd be more than happy to accept it as a patch. It's also, I've put some work into making as many of the fixers as infinite as possible. but there are some that are not. So like the example of this is if you run 2 to 3 over one branch of a source tree, and then you want to run it a different set of fixtures over a different set of the tree, and there's some overlap, the area of overlap isn't going to, it may be changed in ways that it shouldn't be. Most of the fixtures are, and there are certain cases where a construct is legal in both Python 2 and Python 3, but it does different things. And there's no good way for us to tell which language you're writing in. The other one it doesn't handle particularly well is rare cases. Things that are legal, things that are legal in Python 2 that are going away in Python 3, but that don't occur very often in practice. One of these is this. Now, normally, for most values of v, you can translate the top statement into the bottom statement pretty confidently. However, there are cases where that is the absolute wrong thing to do. It's a corner case of the language that is going away in Python 3. And as far as I know, is a remnant from the 1.5, 1.4 days. Anybody know what it is? Not string exceptions. That's not the, at least that's not the one I'm thinking of. And multiple exceptions? No, not really. Yeah, it could be an instance of my exception already. Or in more interesting cases, if it's an exception instance but not my exception. In Python 2, if v is an instance of an exception class, it's not my exception. What the effect is to cast the exception into a new type, so that subsequent except clauses have to match against my exception rather than the actual class of the exception. So this is an example of that would be mistranslated. And it's very, very rare. I've only seen this in all the projects that I've run this over to test it. It's only occurred like 4 times, and that was only in the standard library in code that was originally written in like 1994. So it's pretty rare, but 2 to 3 doesn't handle it. And it's something that I'd like to work on. And that's actually one of the features that I'd like to implement in the future, or if anyone's interested in working on doing. I'd like the fixers to be able to rank how confident they are in the translation. I'd like to be able to, for them to be able to say, I'm 95% sure that this is the right way to go, or I'm 80% sure that this is the right way to go, or I'm 50% sure that this is the right way to go. And I'd like there to be, like, you could set a threshold where you could say, if any fixer is less than, say, 90% confident in translation, drop me into an interactive mode and let me inspect it, show me a diff of the proposed translation, give me the ability to either accept, reject, or edit the translation manually. I'd also like to add annotation, some sort of pragma, so that it can know to skip certain lines. You can say, you may think this is not going to be legal in Python 3, but I know better than you. You should be able to tell it you know better than it does. I'd also like to work on performance, both the performance and the expressiveness of the little pattern matching DSL. It was, the current implementation was written by Guido in what I can only assume was a severe code binge. Because it's not commented at all. I don't understand it. And I've asked him, he doesn't understand it. So it's a little hard to modify. It has a test suite, but modifying the thing isn't the easiest thing in the world. And
is it also written in Ruby?
No, it's not written in Ruby. It's written in Python. But so it's just doing the are you interested in this node part of the process takes like 99% of the runtime. I ran 2 to 3 over Twisted at one point, and it took 6 minutes and 37 seconds to run over Twisted. And of that time, 6 minutes and 34 seconds was spent just in that, are you interested in this node part? And so that clearly needs to come down in time. I'd also like to increase the expressiveness of it, because currently it's basically a regex. And I'd like for it to be able to express recursion. I'd like for it to be able to say, like, the best example of this is if you're looking for an identifier in an assignment, in the left-hand side of an assignment statement, it'd be really nice if I were looking, say, if there were a bunch of nested tuples. I'd like to be able to scan through all of those nested tuples in the pattern matching language, rather than having to write some recursive Python code myself to scan through them. And that would be a colossal one. So if anybody's really interested in like compilers and stuff like that, talk to me. So that is the end of my talk. And I realize that I'm cutting into your lunch time, so I was trying to be brief. And so if any of you have any questions,
I noticed it's designed already to, or sometimes to run on Python 2.3, and so that it has code to check for other Python, but on board this, what's the rationale?
so it does support running in Python 2.3, 2.4, 2.5, 2.6. And a lot of the rationale for that was just me being anal. There's no, like, you're not expected to port an application from, say, 2.3 all the way directly to 3.0. It's mostly just microservices.
I would propose to break that comparatively. Would that be a problem?
I don't think it would be a problem to break it, but come talk to me about what you're thinking of.
I'm actually really glad to hear that it supports some of that. It seems like the Nokia Symbian 60 version of Python is like 2.2 and 2.3, so it's nice to know. So that we can eventually get directly ported, because I doubt we're going to go into 2 steps.
Just point out the Nokia Symbian 60, the version of Python that runs on that's based on 2.2 or 2.3.
Could you show again the slide of the step?
Yeah. Other questions? So the question is, will 2.6's 3.0 compatibility mode pick up on, say, misusing strings in Unicode, even if it doesn't necessarily fix it? And the answer is, the 3.0 compatibility mode isn't designed to tell you how to fix it. It's just more there to point out problems. And more to say, you are going to need to think about how to port this particular part of your application, because it's not going to work. And in a way that we don't necessarily know how to automate it. Some of the warnings that it emits may be able to tell you this is specifically what you're doing wrong, but some of them are, and will be pretty vague. They'll just say. Other questions? on it. That may be all I talk to. You're welcome. So is the infrastructure going to be used for anything other than just this translation? The answer is yes. It's currently being used within Google to translate to clean up on our build files that all of our build system is based on effectively Python syntax. And 2 to 3 is being used to translate, apply style cleanups to these things. So it is being used. It's a very flexible architecture. Thomas Walters was talking to me the other day about a possible 3 to 2 project, which would allow you to write your code to work in Python 3, and then you would run it over and you would say, all right, translate this back to Python 2.4, and it would do that. And so that would be an additional use of the same infrastructure. It's flexible enough you